The ocean hides something terrifying. Out of calm seas, without warning, walls of water taller than buildings rise and vanish. For centuries, no one believed they were real. But the truth is far stranger and far more dangerous than anyone imagined. I am Archid, and you are watching Planet Uncovered, the ocean's hidden menace. The ocean has always been a place of mystery. It covers more than 70% of our planet, yet most of it remains uncharted, dark, and alien. For centuries, sailors have whispered about strange phenomenon on the high seas. Glimpses of lights deep beneath the waves, ghostly ships that vanish without a trace, and, most terrifying of all, walls of water that rise suddenly from a calm surface. Imagine standing on the deck of a ship, staring out at an endless horizon. The sea appears steady, predictable, even peaceful. And then, without warning, a wave taller than a 10-story building surges up out of nowhere. It looms like a liquid cliff, rushing forward with unstoppable force. To those who encountered it, the experience was unforgettable, often catastrophic. Entire vessels were swallowed, crews lost, their stories drifting into history as little more than rumors. For generations, such tales were dismissed. Scientists, naval authorities, even shipping companies considered them nothing more than sailors' lore, exaggerations born from fear and fatigue during long voyages. After all, the mathematics of ocean waves seemed to forbid such monsters. According to the best models of the time, the ocean simply wasn't capable of producing such towering anomalies. And so, the stories of freak waves, as sailors called them, became legends. They were filed away alongside myths of krakens and sea serpents, dramatic, entertaining, but scientifically impossible. At least that's what the textbooks said. But doubt lingered. Too many ships had disappeared in seemingly calm waters. Too many captains, officers, and crew members risked their reputations to swear that what they had seen was real. Were they all lying? Were they all mistaken? Or was the ocean hiding something extraordinary, something the scientific community had overlooked? It is here, in the tension between myth and measurement, that the story begins. Because in time, proof would surface. Hard evidence would confirm that these giant waves do exist. And not only that, they are far more common and far more dangerous than anyone once believed. So the question becomes, how could the world's oceans give rise to such colossal forces of nature? Why did scientists refuse to admit their existence for so long? And what does this tell us about the vast, unpredictable power of the sea? The answer is both unsettling and awe-inspiring. Maritime myths and sailors' testimonies. Long before satellites orbited the Earth and long before steel hulls crossed the Atlantic, sailors of wooden ships carried with them a fear that could not be named on any chart. They spoke of monstrous waves that appeared suddenly, not the long rolling swells of an ordinary tempest, but towering walls of water, so steep, so abrupt that even the sturdiest vessel seemed like a toy in comparison. In the 18th and 19th centuries, captains returning from voyages would sometimes record these encounters in their logs. One ship's journal might describe a wave striking from an otherwise calm horizon, rising as high as the main mast before crashing down with enough force to shatter decks. Another might tell of men swept overboard when the sea rose vertically beneath them. These logs often spoke in a tone of awe, mixing the precision of a sailor's measurement with the raw language of fear. Yet, despite the consistency of such reports, they rarely reached beyond the maritime world. To scientists and scholars on land, these were little more than sailors' tales. Exaggerations, it was said, born from long weeks at sea. And perhaps from their perspective, this dismissal made sense. The idea that calm seas could suddenly give birth to a 20-meter wall of water seemed impossible to reconcile with the known behavior of waves. Still, the stories persisted. One famous case came in the mid-19th century, when the British vessel Ramillies was said to have encountered a wave so vast it carried away much of her rigging and nearly capsized her. In another account, the clipper ship Helen of Troy was struck in the Atlantic by what the crew swore was a liquid mountain. The ship survived, but barely. Many others were not so fortunate. As the 20th century dawned, the ocean was no less merciless. During World War II, Allied forces lost ships in circumstances that puzzled investigators. The German battleship Scharnhorst reported being hit by a wave so large it flooded her deck and damaged equipment designed to withstand the harshest conditions. Even mighty warships, built for the rigors of combat, were not immune. Then there were the disappearances. Ships vanishing without distress signals, their fates written only in insurance reports and whispers on the docks. Families wondered if storms or enemy action were to blame. But to the sailors who had seen rogue seas firsthand, another possibility always loomed. A single, monstrous wave rising out of nowhere, overwhelming a vessel before it had the chance to cry for help. But the tension between these testimonies and the scientific establishment only grew. Naval authorities and academics often rejected such explanations outright. How could a ship's crew measure accurately in the chaos of a storm? Were they not prone to exaggeration, their perceptions distorted by fear? To many on land, the seafarer's story was considered unreliable evidence. This gap between anecdote and science created an almost mythological era around these waves. To sailors, they were real, a threat to be respected and feared. To scientists, they were little more than legends, grouped alongside sea serpents and mermaids. The ocean was already dangerous enough without inventing new terrors. And so, for decades, maritime culture lived with a strange duality. Sailors continued to whisper about the killer waves that struck without warning, while the academic world insisted that such phenomena could not exist. It was a stalemate. Experience against theory, testimony against probability. Yet, as the decades passed, something began to change. Reports of extraordinary waves became too numerous to ignore. Stories from seasoned captains, men with decades at sea, carried a weight that could not be dismissed forever. Ships designed for modern navigation and equipped with stronger materials still found themselves battered by walls of water that should not have been there. The question was becoming unavoidable. Were these seafarers truly exaggerating, or had science underestimated the ocean? The scientific consensus. Why they said it was impossible. For much of the 20th century, science seemed certain about the ocean's limits. Waves, it was believed, behaved in orderly, predictable ways. They rose and fell according to well-defined patterns, driven by the steady push of wind and the vast movements of currents. This view was not guesswork. It was grounded in mathematics, models, and decades of observation. And in those models, there was no room for giants. At the heart of this confidence lay something called linear wave theory. Developed in the 19th century and refined in the early 20th, it treated the ocean as a system of overlapping waves, each passing through each other without interference. According to this framework, the size of waves followed a kind of statistical hierarchy. Small waves were common, medium waves less so, and the very largest waves were extraordinarily rare. The equations worked well for most everyday conditions. They accurately described the long, rolling swells familiar to mariners. They could predict the typical heights seen during storms, and they explained why waves seemed to fall within an expected range. But the same equations also implied strict limits. In theory, waves much larger than twice the significant wave height, the average of the tallest third of waves, should be almost impossible. For scientists, this meant rogue waves were not only unlikely, they were mathematically forbidden. If a ship reported being struck by a 25-meter wall of water in seas where the significant wave height was only 6 or 7 meters, the theory said it simply couldn't happen.
The numbers didn't allow for it. And so, when mariners returned with stories of colossal walls of water, researchers dismissed them as exaggerations or misperceptions. Perhaps the crews had mistaken the steepness of a wave for its true height. Perhaps fear had inflated their memories. Or perhaps in the chaos of a storm, it was impossible to measure anything accurately at all. There was another layer to this skepticism: statistics. When scientists ran probability models, they found that waves exceeding those theoretical limits should occur only once in tens of thousands of years at any given location. In other words, they were so improbable that they could effectively be treated as non-existent. This statistical reassurance gave comfort to shipping companies, insurers, and naval planners. It suggested that while the sea was dangerous, it was at least a danger that could be calculated, managed, and designed against. Ships could be built with safety margins based on predictable extremes. Risk could be quantified and uncertainty tamed. In that sense, the denial of rogue waves wasn't merely stubbornness. It was a logical conclusion drawn from the best tools available. The ocean was vast and chaotic, but it was also governed by physics, and physics appeared to place hard boundaries on what was possible. Yet beneath the certainty, unease remained. If the models were correct, why did experienced sailors continue to describe encounters that defied explanation? Why did some shipwrecks occur in conditions that, statistically speaking, should not have been fatal? The scientific consensus was firm. Rogue waves did not exist, but the ocean, as it would soon prove, had little interest in consensus. Early cracks in the denial. For decades, the model seemed unshakable. Rogue waves were dismissed as myths, their existence barred by mathematics and probability. Yet the ocean was not finished challenging theory. Slowly, cracks began to form in the scientific wall of denial. It started, as it often does, with those who faced the sea directly, modern mariners and the ships they commanded. By the mid-20th century, cargo vessels were larger and sturdier than the wooden ships of centuries past. They carried radar, radios, and better navigational tools. But despite these advances, captains continued to file unsettling reports. Waves far higher and steeper than any forecast had ever predicted, striking suddenly and without warning. Insurance companies began to notice patterns that science could not explain. Certain losses at sea seemed inconsistent with the conditions recorded at the time. Ships built to withstand storms were disappearing in weather described as moderate or manageable. Investigators could not point to icebergs, collisions, or sabotage. What remained were mysterious entries in maritime records, phrases like "overwhelmed by seas" or "lost without distress signal." The tension deepened in the early 20th century when naval fleets themselves began to take notice. Warships designed to endure battle sometimes returned battered from encounters their crews swore had nothing to do with enemy fire. Waves had ripped equipment from decks, shattered windows, and twisted steel. Naval inquiries recorded the testimonies, but often classified them away, unwilling to challenge the prevailing scientific consensus. To admit the existence of waves beyond calculation was to admit a dangerous unpredictability into naval planning. Still, the stories multiplied. The advent of commercial passenger liners brought new witnesses, civilian travelers, journalists, even politicians, all claiming to have seen or felt the strike of an immense wall of water. These were not nameless sailors whose tales could be dismissed as superstition. These were credible observers, men and women whose voices carried weight. And yet, even as evidence accumulated, science remained cautious. The reports were troubling, but they lacked hard proof. No instruments had captured these events. No photographs or reliable measurements existed. Without data, the stories were destined to remain anecdote. But doubt was taking root. When seasoned sailors risked their reputations to insist on what they had seen, when modern ships returned damaged without storms to blame, when losses mounted without explanation, Science could no longer turn away entirely. Something was happening at sea, something that theory had not accounted for. The question was no longer whether sailors were exaggerating. The question was how long the ocean could keep its secret before it finally revealed undeniable evidence. The turning point, the Draupner Wave, 1995. The stalemate between story and science held for generations. Sailors insisted that rogue waves were real. Scientists dismissed them as illusions. But on the first day of 1995, the ocean itself delivered a verdict that neither side could ignore. Far off the coast of Norway, an oil platform named Draupner stood anchored in the North Sea. Built to endure brutal conditions, it was equipped with state-of-the-art sensors designed to record everything the sea could throw at it. On January 1st, as storms swept across the region, the Draupner platform faced waves that were powerful but ordinary, nothing outside the expected range of winter seas. At least until one extraordinary wave rose from the depths. Without warning, a single wall of water surged upward. Instruments measured its height at 26 meters, nearly the height of a 10-story building. It struck with staggering force, slamming into the platform and surging over its deck. Yet Draupner was built to survive. The platform remained standing, and its sensors, running the entire time, captured the event in precise detail. For the first time in history, the existence of a rogue wave was no longer anecdote. It was measured fact. The data showed a wave that was not only far larger than the surrounding seas, but one that defied every statistical model in use. The Draupner Wave, as it became known, had no room in the equations of linear theory. And yet, there it was, irrefutable, undeniable, and terrifyingly real. The scientific community could no longer dismiss the possibility. Here was evidence gathered not by sailors in the chaos of a storm, but by calibrated instruments on a fixed structure. No misperception, no exaggeration, just hard numbers. The ocean had spoken. The reaction was profound. At first, many researchers met the data with disbelief. Could the instruments have malfunctioned? Had there been an error in calibration? Teams rechecked the recordings again and again, but the result was clear. The wave was real. What had once been a statistical improbability had been captured in black and white. Slowly, skepticism gave way to reluctant acceptance. Conferences that once brushed aside rogue waves as myth now featured them as serious topics of study. Papers were written, models revised, and a new branch of oceanography began to emerge. The Draupner event did more than prove that rogue waves existed. It shattered the illusion that the sea could be fully predicted by neat equations. It revealed that the ocean held chaotic, non-linear processes that scientists had underestimated. What had once been dismissed as sailor's lore was now recognized as a genuine phenomenon, one that was the power to threaten ships, platforms, and lives. From that day forward, the debate was over. The ocean had revealed one of its secrets, and science had been forced to listen. But the Draupner Wave was only the beginning, for if one such monster could be recorded, how many more were out there, unseen, waiting to rise from the deep?
How rogue waves actually form. With the Draupner Wave recorded, the question shifted from do they exist to how are they possible? What could cause the ocean, which seemed to follow predictable rules, to suddenly generate waves the size of buildings? The answer lies in the complexity of water itself, and the fact that the sea does not always play by linear rules. Ordinary waves are relatively easy to describe. Wind blows across the surface of the water, transferring energy into ripples that grow into swells. These swells travel vast distances, combining with one another in ways that can usually be predicted. For decades, scientists relied on this linear model. Waves pass through each other like overlapping ripples in a pond, and their combined height is just the sum of their parts. But rogue waves reveal that the ocean does not always remain linear. Instead, under the right conditions, it becomes non-linear, and this changes everything. One mechanism is constructive interference.
Normally, waves of different sizes and directions cancel each other out as often as they combine. But every once in a while, multiple wave crests can align perfectly, stacking their energy into a single towering wall of water. For an instant, dozens of ordinary waves cooperate, and the result is something extraordinary. Another mechanism involves focusing of wave energy. Ocean currents, like the powerful Agulhas current off South Africa, can act like a lens. When opposing waves run into these currents, their energy compresses into shorter, steeper, and far more dangerous forms. A wave that might otherwise have been harmless can suddenly surge upward into a rogue giant. And then there is nonlinear instability, a process in which small variations in wave height don't just add together, they amplify each other. In this scenario, one wave grows at the expense of its neighbors, feeding on surrounding energy until it towers far above the rest. This runaway effect can create a rogue wave even in conditions that appear stable. Together, these mechanisms explain why rogue waves can emerge out of calm seas, without the warning of a storm. The ocean's surface might look ordinary one moment, only for a massive wall of water to rise the next. But if physics can be described, why are these waves still so difficult to predict? The answer lies in scale and chaos. The ocean is an unimaginably vast system with countless variables: winds, currents, swells traveling from distant storms, shifting temperatures, even the contours of the seabed. Trying to calculate when and where all these forces will converge is like predicting the exact location of a lightning strike. Satellites and computer models have improved our understanding, but the chaotic nature of the sea means predictions can rarely be precise. Rogue waves are not regular phenomena. They are born from chance alignments and runaway effects that defy simple forecasting. This is why they remain so dangerous. A ship's crew might have no warning before facing a vertical wall of water. Even with modern instruments, the best we can often say is where rogue waves are more likely to occur, not exactly when or how. What once seemed like maritime legend is now understood as a product of physics pushed to its extremes. But knowing the theory does not make the ocean any less dangerous. For the sailors who encounter these monsters, understanding why they form is little comfort in the moment when one suddenly rises before them. Legendary encounters at sea. The proof provided by the Draupner platform was undeniable, but long before 1995, there had been encounters that hinted at the truth. Stories so extraordinary that they were often dismissed as exaggeration, yet carried the weight of survival. One of the most famous cases occurred during World War II. The RMS Queen Mary, a massive ocean liner converted into a troop ship, was transporting thousands of soldiers across the Atlantic. In December 1942, she was struck by a rogue wave estimated to be nearly 28 meters high. The ship, over 300 meters long and weighing more than 80,000 tons, was rolled violently onto her side. For a few terrifying seconds, it seemed certain she would capsize, but the Queen Mary managed to right herself, narrowly avoiding disaster. Eyewitnesses recalled the sensation of being lifted, as though the entire vessel were nothing more than driftwood. For decades, skeptics questioned the account, claiming that no wave could possibly endanger a ship of that size. Today, the story is recognized as one of the earliest modern records of a rogue wave's devastating power. Another dramatic encounter came in 2001 when the German cruise ship MS Bremen was sailing in the South Atlantic. The vessel was struck head-on by a rogue wave, so powerful it shattered windows on the bridge and disabled its navigational instruments. For hours, the ship was adrift in dangerous waters, its crew struggling to regain control. Passengers later spoke of seeing a sheer wall of water blotting out the horizon, a memory they could never forget. The Bremen's ordeal was not unique. Just weeks earlier, the MS Caledonian Star suffered a similar fate. These near disasters forced investigators to re-examine what was once thought impossible. Testimonies from survivors painted a vivid picture of the terror. Sailors often described the approach of a rogue wave as unlike anything they had ever seen. A steep, vertical wall that rose from calm seas, leaving no time to prepare. Some compared it to a moving cliff, others to a black wall blotting out the sky. The impact was described as violent beyond measure. Metal twisted, windows imploded, decks torn apart. Those who lived through these encounters carried the memory for the rest of their lives. But for much of the 20th century, these accounts were treated with suspicion. Maritime authorities hesitated to acknowledge them, fearing panic or insurance complications. Scientists dismissed them as faulty perception, the frightened exaggerations of sailors in rough weather. But as more reports accumulated, and as technology finally began to capture these waves in real time, the weight of testimony could no longer be ignored. These legendary encounters serve as a reminder. Long before instruments recorded the Draupner Wave, the ocean had already revealed its secrets to those who dared cross it. The difference was that only survivors lived to tell the tale, and for too long, their voices went unheard.
The role of satellites and modern observation. For centuries, the only evidence of rogue waves came from those who survived them. Then, in 1995, the Draupner platform finally delivered hard proof. But it was in the years that followed, when satellites turned their gaze to the oceans, that the scale of the phenomenon was truly revealed. In the early 2000s, the European Space Agency launched a project known as MaxWave, using radar satellites to scan the world's oceans. The mission had a simple goal: to determine whether rogue waves were as rare as theory predicted. What it found stunned the scientific community. Over the course of just 3 weeks, satellites detected more than 10 individual rogue waves, each rising higher than 25 meters. To put that into perspective, these waves were as tall as a 9-story building, appearing not once in centuries, but multiple times in less than a month. The discovery was nothing short of shocking. For decades, probability models had suggested such waves should occur only once every 10,000 years at any given location. Yet here they were, recorded repeatedly in mere days of observation. The conclusion was inescapable. Rogue waves were not extreme outliers. They were part of the natural behavior of the sea. NASA satellites soon added to the picture. Using instruments designed to measure sea surface heights with extreme precision, they too recorded sudden anomalies, waves rising far above the surrounding ocean. What once seemed mythical was now a measurable global reality. But the satellites revealed more than just existence. They revealed patterns. Rogue waves were not distributed randomly across the globe. Instead, they appeared more frequently in regions where powerful ocean currents collided with prevailing winds or opposing swells. The Agulhas Current, off the coast of South Africa, became notorious as one of the most active hotspots, where massive rogue waves routinely threatened ships rounding the Cape. The North Atlantic, especially during winter storms, also emerged as a breeding ground. And in the Pacific, shipping routes that crossed the paths of strong currents showed higher risks than previously imagined. This global mapping changed everything. Maritime industries that had once dismissed rogue waves as improbable began to accept them as a regular hazard. Insurance models were updated. Naval architects were forced to reconsider ship designs. What had been written off as sailor's lore was now confirmed by the impartial eye of satellites orbiting hundreds of kilometers above the Earth. Perhaps the most unsettling revelation was not just where rogue waves appeared, but how often. Far from being once-in-a-lifetime anomalies, they were happening with startling regularity. Invisible to human eyes, but captured in digital snapshots from space. The ocean was far more volatile, far more unpredictable than anyone had dared to imagine. In less than a decade, the combination of the Draupner platform's data and satellite observations transformed rogue waves from legend to accepted science. But with acceptance came a sobering reality. Knowing these waves exist does little to reduce their danger. Ships still sail through waters where, at any moment, the horizon may rise into a wall of water. Modern science and safety at sea.
Today, rogue waves are no longer dismissed as fiction, but recognized as one of the greatest threats of the open ocean. With acceptance has come a new challenge: how to live and sail with them. The first step has been monitoring. Modern ships are now equipped with wave radar systems capable of detecting sudden anomalies in the surrounding sea. Coastal stations and ocean buoys linked to satellites form an expanding global network that feeds real-time data into predictive models. Scientists use this information to anticipate dangerous sea states where the chance of a rogue wave is elevated. Yet even with all this technology, accurate prediction remains elusive. Rogue waves form quickly, often in minutes, and their exact appearance is still beyond our forecasting abilities. In response, the focus has shifted toward designing ships to survive them. Naval architects now account for the possibility of a 25-meter or higher impact when stress testing hulls. Bulk carriers and cruise liners are built with reinforced bows and improved structural resilience. Even windows and bridge equipment are engineered to withstand sudden hits from towering seas. The lessons learned from the Draupner Wave and subsequent satellite data have reshaped the very way ships are conceived. But the danger is not just physical, it is also economic. Each year, rogue waves contribute to maritime losses worth billions of dollars. Insurance companies, once skeptical of such claims, now include rogue waves in their risk models. Premiums for vessels traveling through high-risk corridors, such as the South Atlantic or the North Sea, reflect this hidden menace. For shipping companies, these costs ripple outward, affecting global trade and the price of goods moved across oceans. Despite these advances, there remains an uncomfortable truth. No amount of engineering or economic preparation can eliminate the risk entirely. Rogue waves continue to rise, unannounced, out of seemingly ordinary seas. They remind us that the ocean is not fully under human control, that it still harbors forces capable of humbling even the largest vessels ever built. Modern science has brought us closer to understanding, and modern technology has made us better prepared. But when a wall of water taller than a building appears on the horizon, it is a reminder that safety at sea will always be a balance between knowledge, preparation, and respect for the unpredictable power of the ocean. The ocean's final mystery. For all that we have learned, rogue waves remain among the least predictable forces of the natural world. Satellites can map them, ships can endure them, and supercomputers can simulate their formation. But the ocean still guards its deepest secrets. One of the greatest unanswered questions is how often rogue waves truly occur. Some estimates suggest thousands may rise across the globe each year. Others argue that they're far rarer. The truth is obscured by the sheer scale of the ocean, where most of these giants vanish unseen. Only the few that collide with ships, oil platforms, or buoys leave a measurable trace. Another mystery lies in their upper limits. The Draupner Wave reached 26 meters, but could they grow larger? Some computer models suggest waves over 30 or even 40 meters are possible under rare conditions, tall enough to rival skyscrapers. But no one can say with certainty how high the ocean's fury can climb, or whether such a wave has already risen in some forgotten storm, unobserved, and passed into history without a witness. Then there's the question of coastal impact. Rogue waves are usually thought of as deep ocean phenomena, but could a giant wave formed far offshore travel landward and strike without warning? Evidence is scarce, but some unexplained coastal floods and mysterious maritime disasters hint at the possibility. If so, the implications for coastal communities are profound. In the end, these questions reflect a deeper truth. Science can measure, calculate, and model, but the ocean does not always obey human rules. It is not a machine churning predictably, but a restless, dynamic force, shaped by winds, currents, and the rotation of the Earth itself. And so the rogue wave stands as both a scientific puzzle and a symbol. a reminder that even in the age of satellites and global observation, there are still forces on our planet that defy easy prediction, forces that demand respect. The ocean is not just vast, it is alive with motion, with power, and with mystery. For those who venture across its surface, it is both a pathway and a peril. And for us who watch from the safety of shore, it is a humbling reminder that nature still holds the final word.